Are you ready for some news that'll blow your mind? This episode will discuss two breakthroughs that will change the world: Google Gemini AI and FAN, a real-time robotic vision system. These are two of the most amazing and impressive innovations in AI right now, and we will explore them in depth. Don't miss this because it's going to be awesome. What is Google Gemini? Gemini is Google's next-generation foundation model. It follows on from Palm 2, the current AI model behind Google's Bard chatbot and other recently announced features. Once launched, Google's Gemini is still in training mode and is expected to be a key rival of OpenAI's GPT. Gemini is a multi-modal AI that can handle and generate different types of data and tasks, such as text, images, audio, video, speech, natural language, code, logic, and more. It can learn from any domain and source of information, such as books, websites, social media, podcasts, and more. It can also collaborate with other tools and APIs and accommodate future developments. Gemini can help users with various goals and interests, such as writing essays, learning skills, and conversing. Gemini is based on a novel architecture that combines deep learning and symbolic reasoning with self-attention to learn from data and generate outputs efficiently and effectively. Gemini is powered by a massive network of self-attention layers called Vision Transformer, or VIT. VIT is a state-of-the-art model that can process any type of data such as text, images, audio, and video using the same architecture and parameters. VIT is based on the Transformer model, originally developed for natural language processing and generation, but has since been adapted for other domains and modalities. VIT is a generative AI that can handle and create different data types, such as text, images, audio, video, speech, natural language, code, and logic. VIT consists of two main components, an encoder and a decoder. The encoder transforms the input data into a sequence of symbols called tokens. The tokens represent the features or meanings of the input data. The decoder takes a sequence of tokens and transforms it back into the output data. The output data can be the same or different from the input data, depending on the task or goal. The encoder and the decoder use self-attention layers to learn from the data and generate the outputs. Self-attention layers are neural network layers that allow VIT to focus on the relevant parts of the data based on their context and importance. For example, if it reads a text document, it can use self-attention to focus on the keywords or phrases most relevant to its task or goal. Or if it is generating an image or a video based on a text description or a voice command, it can use self-attention to focus on the details or features most relevant to its task or goal. Self-attention layers enable VIT to learn from data and generate outputs more effectively and efficiently. They also enable VIT to handle long data sequences and complex dependencies between data. VIT is a powerful and versatile AI tool that can learn from any domain and source of information to generate any data type. It can also integrate with other tools and APIs to enable wider collaborative efforts. It can also accommodate future developments such as improved memory and planning. VIT is the core component of Gemini, Google's next-generation AI system. VIT is trained on a large-scale dataset of diverse and multimodal data called Gemini Dataset, or GDS. GDS contains billions of examples of data from various domains and sources, such as books, websites, social media, podcasts, and videos. GDS also contains labels and annotations for each example of data, such as categories, keywords, captions, summaries, questions, answers, and more. VIT and GDS enable Gemini to learn from diverse information and feedback, and perform well on various data and tasks. Gemini can also fine-tune or extend its model for new data or tasks. Gemini is modular and extendable and can collaborate with other tools and APIs. Gemini can also offer new features and functionalities for users such as Duet AI, Help Me Write, and AI Integrated Search. Gemini can also customize its model for specific domains and applications, such as MedPal M2 for health-related topics. Gemini is a powerful and responsible AI model that can provide secure and robust solutions for cybersecurity analysis and other tasks. Google follows its principles for responsible AI development and applies them to Gemini, such as being socially beneficial, avoiding unfair bias, being safe and accountable, respecting privacy, upholding scientific excellence, and being used ethically. Google has been collaborating with other stakeholders, such as researchers, developers, regulators, and users, to ensure that Gemini is aligned with the values and expectations of society. Google has been engaging in dialogues and consultations with these stakeholders to solicit their feedback and input on Gemini's development and deployment. Google has also been sharing its research and insights on Gemini with the public and the academic community to foster openness and collaboration. Google Gemini is a game-changing AI model that will transform how we interact with data and information. It will enable us to access, create, and communicate data in any modality. It will also empower us to learn, explore, and discover new things in any domain. Google Gemini is the ultimate AI model that can do it all. But Google Gemini is not the only AI breakthrough that we'll discuss today. There is another one equally impressive and important. FAN, a real-time robotic vision system that can see and manipulate objects in 3D. What is FAN? FAN stands for Fast Adaptive Neural Rendering, a system that can generate realistic 3D images of objects from any viewpoint and under any lighting condition. FAN can also use these images to control a robotic arm that can grasp and manipulate these objects in the real world. The FAN is a joint project between Google Research, Stanford University, and the University of California, Berkeley. It was recently presented at the International Conference on Computer Vision 2023, winning the Best Paper Award. According to researchers, FAN is a breakthrough in computer vision and robotics because it can achieve high-quality 3D rendering and manipulation in real time. This has been very challenging for previous methods, requiring much computation time or producing low-quality results. But how does FAN work? How does it achieve this level of performance and quality? Well, FAN uses a combination of neural networks and geometric optimization. The FAN has three main components: a neural renderer, a neural controller, and a robotic arm. The neural renderer is the component that generates the 3D images of the objects. It takes as input a 2D image of an object from a single viewpoint and outputs a 3D image of the same object at any desired viewpoint. The neural renderer uses a convolutional neural network to learn the shape and appearance of the object from the input image. It then uses a differentiable rendering technique to project the learned shape and appearance onto the output image. The neural controller is the component that controls the robotic arm based on the 3D images generated by the neural renderer. It takes as input a goal image of an object in a desired pose or configuration, and outputs a sequence of actions for the robotic arm to execute. The neural controller uses a recurrent neural network to learn the dynamics and kinematics of the robotic arm from previous actions and outcomes. It then uses a reinforcement learning technique to optimize the actions for achieving the goal image. The robotic arm is a component that executes the actions output by the neural controller. It is a standard 6 degrees of freedom robotic arm with an RGBD camera and a parallel jaw gripper attached to its end effector. The robotic arm can move in 3 dimensions and rotate around 3 axes. The RGBD camera provides color and depth information for the objects in its field of view. The parallel jaw gripper can open and close to grasp or release objects. By using these 3 components together, FAN can achieve real-time 3D rendering and manipulation of objects. The FAN can handle objects of various shapes, sizes, colors, textures, and materials. FAN can also handle objects under various lighting conditions such as natural light, artificial light, shadows, and reflections. FAN can perform various tasks with these objects, such as picking, placing, rotating, aligning, stacking, and more. FAN can also learn from its experience and improve its performance over time. The FAN is a remarkable and useful system that can automate and optimize various manufacturing, logistics, healthcare, education, and entertainment tasks. It can help with production, assembly, transport, sorting, delivery, storage, diagnosis, treatment, teaching, training, learning, development, design, and interaction of products, parts, goods, materials, patients, diseases, students, skills, games, and toys. The FAN is a groundbreaking system that will transform how we see and manipulate objects in 3D. It will enable us to generate realistic 3D images of objects from any viewpoint and under any lighting condition. It will also empower us to control a robotic arm that can grasp and manipulate these objects in the real world. The FAN is the ultimate system that can do it all. And that's it for today's episode. We hope you enjoyed learning about these 2 amazing breakthroughs in AI, Google Gemini and FAN. These are 2 of the most advanced and impressive AI innovations, and they are all set to change the world as we know it. Thanks for watching, and don't forget to like, share, and subscribe to our channel for more AI news and updates. See you next time, goodbye.